Welcome you all in the course Mechanical and Electrical Safety, MIS 024. I am Dr. Naqi Anwar from Terry School of Advanced Studies, New Delhi. Under this course, I am going to explain two separate topics today. The first is work permit system and the second is earthing and leakage current management for safety. So let's begin with the work permit system. Work permit is a written consent of the owner or the issuing authority that guarantees proper and safe conditions where working personnel can work safely by complying with the instructions of the permit. It also indicates that people executing job have reviewed the permit and accept responsibility of adhering to the instructions and limitations stipulated. Thus, a permit essentially becomes a document of consent by both the parties, that is the owner or the issuing authority and the job executor. Work permit also assured that the work is going on with permissions and under authorized bodies which is capable of handling all safety and security issues. So now we will look at the applicable regulations on the work permit system. So regulation 19(3) of CEAR 2010 deals with handling of electric supply lines and apparatus, according to which it is mandatory to get authorization before working on any line or apparatus. Central Electricity Regulation 2010, Regulation 19(3) also states that no person shall work on any live electricity supply line or apparatus and no person shall assist such person on such work unless he or she is designated in that behalf and takes the safety precautions given in Schedule 3. In continuation to the applicable regulations, we can see that Schedule 3 explicitly mentions what precautions needed to be taken. One of the precautions to be observed pertaining to work permit system under Schedule 3 are work permit will be taken from the terminal substations at each end of the lines. Further, Regulation 3 of CEAR 2010, that is Central Electricity Authority Regulations 2010 for industrial safety, also provide the information about designated persons to operate and carry out the work on electrical lines and apparatus, which says designated person is required to have certificate of competency or work permit issued by appropriate government body and his name entered in proper register. Classification of work permit, that is what are the types of work permit available. So there are 5 types of work permits available. First is general work permit, second is hot permit, third is electrical work permit system, fourth is working at height permit, and 5 is the permit for excavation work. We will discuss the third, that is electrical work permit system, in detail, but also explain the other 4. General work permit, this is a permit issued for works of routine nature such as housekeeping activities, replacement of used lamps or other luminaries, or even replacement of fans at the industrial premises. Hot permit, it is issued for work related to use of heat or generation of heat that is sufficient to ignite gases, vapors, fumes, dust, etc. Some of the examples where hot permit is required during industrial operations are welding, flames, cutting metals, drilling, soldering, sandblasting, grinding, etc. Electrical work permit system we will be discussing upon now. Work on electrical installations, equipment and apparatus is considered to be very hazardous. Therefore, it is of utmost importance that sufficient safety precautions are taken before carrying out any work on electrical circuits, lines and equipments. Hence, to exercise greater control over such work and to ensure that adequate precautionary measures are taken before commencement of the work on electrical equipments, an electrical work permit system shall be developed. The permit is issued to carry out work on electrical equipment installation after completely de-energizing the equipment from electrical energy and providing electrical grounding. The electrical permit shall clearly indicate the equipment or installation under work, the person who is handling the work, duration of the work, type of the work that is to be carried out, points of isolation, grounds provided to the equipment and additional precautions required if any. The permit shall be signed by issuing authority and also by the executing authority. All work shall be carried out under supervision of a competent supervisor. If more than one departments are working on the same apparatus, a permit to work shall be issued to the person in charge of each department. No construction, repair or maintenance work is permitted in the proximity of high or extra high voltage systems or equipments, whether it is electrical or mechanical, where technical knowledge or experience is required to avoid the danger. So, in continuation to the specifications of electrical work permit system, the construction, repair or maintenance work shall not be carried out unless a permit of work on the prescribed form has been issued by the shift in charge to an authorized person. The person issuing a permit to work shall ensure that the system or the equipment is made perfectly safe for working. In case of electrical system or electrical equipment, the isolation shall be complete, the metal parts adequately earthed and danger notices attached at suitable places. Now we will look at the working at height permit. In the event of any working person required to stand, pass over or bear any roof or ceiling covered with fragile material or required to work at an elevation of more than 3 meters height, adequate safety measures shall be provided to prevent falls. For this purpose, it is suggested to use ladders, crawling boards and safety belts, etc. Each time a person is required to work on a fragile roof or at higher elevations, the job shall be carried out under the authority of a work permit issued by concerned department having responsibility of that area. Excavation permit needs to be understood clearly because the originator of the permit having proprietary responsibility of the area where excavation work is intended to be carried out will prepare the excavation permit in duplicate, indicating the exact location where the excavation work will be carried out and send both copies of the permit to the plant maintenance department, and only then the permit is assumed to be completed. Now the plant maintenance engineer studies the relevant drawing of the area to be excavated and determines whether any pipelines or electrical or communication cables are located in that area. If any such obstacles are seen, he or she prescribes the special precaution to be taken while excavating and puts his signature on the permit. Now we will start discussing about the second part of this lecture, focused on earth and leakage current management for industrial safety. So the discussion will be focused on earthing and the grounding system and earth leakage current management. We will start with the earth and grounding systems. So in any electrical installation, an earthing system or grounding system connects particular parts of that installation with the earth conductive surface, mainly for safety and different functional purposes. So it is basically a process to provide a safeguard against the electrical shock. The point of reference is the earth's conductive surface. Leakage current is the residual flow of current through insulation after a high voltage has been applied for a period of time. Earth leakage current is the leakage current from all the earth parts of the product. This leakage current passes from their mains supply through or across insulation into the protective earth conductor. Mind that we are looking at the earth and grounding systems for industrial safety from the regulatory point of view. So we will not discuss the technical details more elaboratively, rather we will be focusing on regulations applied for this particular safety measures. So we were discussing about the leakage current flowing in the ground conductor, which can be measured by connecting the ampere clamp meter in the series with the ground connecting of the device concerned. Leakage current clamp meter is the most common device used to measure leakage current. Now we will look at the earthing for systems with voltage above 150 volt and below 650 volt. So the CER regulations 2010, we will look at the applicable regulations. Under regulation 41, there is a specific provision for earthing neutral wire of a 3-phase 4-wire system and the middle conductor of a 2-phase 3-wire system. Earthing has to be done with 2 separate and distinct connections. The grounding system should also be having minimum of 2 different earth electrodes for proper grounding. Regulation 41(1) in this regard says neutral conductor of a 3-phase 4-wire system and the middle conductor of a 2-phase 3-wire system shall be earthed by not less than 2 separate and distinct connections with a minimum of 2 different earth electrodes, or such large numbers as may be necessary to bring the earth resistance to a satisfactory low value, both at the generating station and at the substations. It further elaborates in 41(2) that the earth electrode so provided should be interconnected to reduce the earth resistance. So you should understand that we are focusing our discussion only on the applicable regulations and not on the technical know-how that how earthing system is to be carried out. For the direct current 3-wire system, regulation 41(4) specifies that the middle conductor shall be earthed at the generating station only, and the current from the middle conductor to earth shall be continuously recorded by means of a recording ammeter. And if at any time the current exceeds 1000 part of the maximum supply current, immediate steps should be taken to improve the insulation of the system. Now in continuation for earthing for systems with voltage greater than 150 volt and below 650 volt, regulation 41(15) spells out the characteristic of all the earthing system, that all earthing system should consist of appropriate equipotential bonding conductors as per relevant Indian standards, so as to maintain all non-current carrying metalworks at earth potential. This regulation further emphasizes on the physical characteristic of earthing system like mechanical strength so as to work properly during its useful life and serve the purpose it is intended for. Now, few details about the earthing system. As we can Recall that earthing system is very important part of electrical safety. All electrical equipments, apparatus, device must properly earthed. Otherwise, there is a fear of electrical shock. So, there are some bounding conditions for earthing system, and all earthing system shall provide the three properties. The first, it must consist of equipotential bonding conductors capable of carrying the prospective earth fault current, and a group of pipes, rods and plate electrodes for dissipating the current to the general mass of the earth without exceeding the allowable temperature limits. As per relevant Indian standard, in order to maintain all non-current carrying metal works reasonably at earth potential, and to avoid dangerous contact potentials being developed on such metal works. Second property is, it must limit the earth resistance to sufficiently low value to permit adequate fault current for the operation of protective devices in time and to reduce neutral shifting. The third property of an earthing system is, it must be mechanically strong, withstand corrosion and retain electrical continuity during the life of installation, and all electrical systems shall be tested to ensure efficient earthing before the electric supply lines or apparatus are energized. Now we are into the last part of our discussion, which is focused on earth leakage protecting devices for leakage current management for industrial safety. So regulation 42 mentions where earth leakage protecting device should be employed. This regulation states that installation with load above 5 kW exceeding 250 volt shall have suitable earth leakage protective device to isolate the load in case of earth fault or earth leakage. An earth leakage circuit breaker, which is known as ELCB, is a safety device mainly used in electrical installations with high earth impedance for safety against shock. ELCB evaluate small stray voltages on the metal enclosures of electrical equipments and interrupt the circuit in case of high voltage. Whatever the source of earth leakage, it must be prevented from causing electric shock. This is usually done by using either RCDs, that is residual current devices, or RCBOs, that is residual current circuit breakers with overcurrent protection. These measure the current in the line conductor and compare it with the current in the neutral conductor. If the difference exceeds the milliampere rating of the RCD or RCBO, it will trip. So these two types of the earth leakage protecting devices, that is residual current devices RCDs or residual current circuit breakers, that is RCBOs, are popularly used for protection against earth leakage or electrical shock. So in this case, these devices are connected in the earth leakage circuit, which is originated from the metallic enclosures of electrical equipments and connected in that particular circuit towards the earth. Most of the time, earth leakage work as intended, but sometimes an RCD or RCBO keeps tripping for no apparent reason. This is called nuisance tripping. The best way to tackle this is with an earth leakage clamp meter, such as a Megger. Megger is a device which is also used for measurement of high resistance. This is clamped around the line and neutral conductors together, but not the protective conductor, and it measures the earth leakage current. So in that way, we can determine the nuisance tripping to decide which circuit is causing nuisance tripping turn off all the MCBs in the consumer unit and position the earth leakage clamp around the main cables. Turn on each circuit in turn. If one causes the earth leakage to increase significantly, this is likely to be the problem circuit. Here, don't forget, the problem might be a faulty RCD or RCBO itself. To check, do an RCD ramp test. If it is a 30 milliampere device, suppose the milliampere rating of the earth leakage protecting device, whether it is RCD or RCBO, is 30 milliampere, which is the most common rating, then it should trip somewhere between 24 and 28 milliamperes when flows through it. If it trips at a lower current, it probably needs replacement. So with this, we are at the end of this lecture, and as we have seen that this was divided into two parts. The first part was related to work permit system, and we have seen that what are the corresponding CEAR regulations needed to define work permit systems, what are the types of work permit systems. There were 5 work permit systems. Out of that, the electrical work permit system has been discussed with further elaboration. The second part of the lecture deals with the earthing and leakage current management, in which we have seen that what are the regulations applied for designing the earthing and the grounding systems, and further we have seen that what it takes to connect earth leakage protecting devices and what are the different earth leakage protecting devices can be there, and how we can provide the leakage current management system in the earth protecting systems. Thank you.